Hi, this video is to talk about time series decomposition. This is a process to decompose the variability in a time series in the following components. One is the trend, that's the overall tendency of a variable along the time. And then we have some variability associated with systemic variation, for example, due to seasons or quarters. And then we have variability that is to the business cycles like growth and recession. And finally, we have some variability that is not related to anything, which we call random error. In the time series decomposition, we have two models to compute the forecast. To compute the demand, to forecast the demand. We have two models. One model is multiplicative seasonality model, in which we multiply a fixed amount for each season. This is the fixed amount we're going to multiply for each season. For example, during summer, demand is 30% higher. In this case, we multiply demand by 1.3. During winter, demand is 30% lower. In this case, we multiply demand by 0.7. And this is the demand that we multiply by the seasonal factor. The sum of seasonal factors is a given number, is any summation. Okay, it doesn't have to be equal to 1. Okay, I'm going to show you how to do this. The following slide, is to show you how to do this. I'm not going to read the steps. I'm going to show you these steps in Excel. So let's take a look at this example. This example comes from our class notes, and this is from this is in page. Let me show you page 16, problem 2. Fireplace company. So let me put here problem 2, fireplace company, if you want to relate to the book. Okay, these are seasons, these are years, and these are the demands for fireplace. So our first step 1, is decompose the factors. So I'm going to decompose the factors for each one of the seasons, and to do that, what I have to type here is the season. In the season we have spring, summer, fall, and winter. And then I need the average. Okay, to compute this average, what I have to do is equal. I'm going to compute the average for demand for only the spring season in this case. Okay, so the average here for the spring season is going to be equal to the demand during spring. To do that, I type equal, open parentheses, and I sum all the spring demand. I select this data points and divide by 3 because I have 3 data points. I divide by 3 to get the average. I do the same thing for summer. So I type equal, open parentheses, and I select summer plus demand for summer in year 2 and demand for summer in year 3. I close parentheses, divide by 3, and then I do that for the fall demand, divide by 3, and finally for winter, equal to demand in winter. Let's take the average here. And then we have for the overall year, which is equal to the average of all this demand, because it's the 3 years we're taking the average. Okay, now we can get the season factor. Okay, the season factor is computed for each one of the seasons by doing this. I get the average for that season and divided by the overall year average. Okay, I do this for summer. I divide this average by the overall average. I divide the fall average by overall average. I divide by winter average by overall average. If I divide this by this, I'm going to have 1. Oops. Divide this by itself, I have 1. So these are the seasonal factors that I'm going to use now for the second step. Oops, I want to reduce the decimal places. Let's do this. Okay, I have the seasonal factors, and then comes my step 2. Step 2 is de-seasonalize the demand. Okay, so I'm gonna de-seasonalize. I'm gonna remove the seasonality from the demand. The way I do that is that I divide my demand of spring by the spring season factor. Okay, I divide my demand in summer by the summer season factor. I divide my fall demand by the season factor, and I do the same thing for winter. Okay, so this is what I do. Let me do that to all demand. This one here, this one here. Oops. This one divided by this one here. And then I divide this one by, oops, for the winter. And I divide again the spring by spring factor. Always dividing each season demand by its factor. Okay, so this is the demand after removing the seasonality. Okay, so let's reduce the decimal places here to make it easier to see. Okay, now comes this step. This is step 2. So let me type here step 2 is the seasonalize the demand by dividing each demand, seasonal demand by its respective seasonal factor. Okay, we put this here. Now comes step 3. Step 3 is estimate linear regression coefficients using quarters, in this case quarters, as the time x variable, and the seasonalized demand as our y variable or dependent variable. Okay, you see that I'm using a variable that doesn't exist, this variable quarter, as a time variable, a variable that determines time. You see that we don't have this variable here, this quarter, we don't have it. So we're going to create that. We're going to insert quarter. Let me put here quarter. So this is the first quarter, second quarter, third quarter, and fourth quarter. Fifth quarter, 6, 7, 8, 9, and so on. Okay. So these are the quarters, and this is going to be my x variable, and this is going to be my y variable. Okay, this will be x variable. This is going to be my y variable in a regression analysis. Remember, you learn regression analysis in class, so we're going to use data analysis. And then I'm going to select regression, okay, and then input your y range. My y range is my seasonalized demand from step 2. What is my x variable? Is quarters. I hit labels because I select the labels, and I'm going to now put the data. I have to do this one here to output the data here. Okay, and hit OK. And I have the regression estimates and results here. So what I'm really interested is in these coefficients. Okay, so I'm going to reduce the decimal places here to make it easier to see. You can reduce decimal places, all place cells, to be easy to just see. Okay, so I'm gonna use these coefficients here to come up with a trend. So my trend, the trend is my the effect. My trend is the effect of quarters. So my trend is 35.99 or 36 units per quarter. Okay, this is the trend. 36, about 36 units every quarter that I'm going further. Okay, the seasonalized demand equation is X, or the demand is going to be equal to 237.05, which comes from here. This is my intercept, that's the constant, and I'm gonna multiply, I'm sorry, this is okay, so this is Y, not X, plus 35, or let's say 36, multiplied by my quarter. That's my seasonalized demand equation. So what I do, so my step 3 is this. I want to first get the seasonal factors, deseasonalize the demand, using this deseasonalized demand as my Y variable to see what's the relationship with this variable along the time. This is, I do step 3, and then in step 4 I extrapolate results to year 4. That is I forecast year 4 using the equation above. Let's say equation above. Okay, so let's do this. Season, spring, summer, fall, and winter, and then quarter, year, trend, and forecast. So my quarter here is the continuation, the number that goes in here is the continuation from this number here. So here is going to be 13, 14, 15, 16. This is year 4. Okay, so my trend here, my trend is going to be equal, my trend, hold on, my trend in this case is going to be equal to 2037.05 units plus the quarter multiplied by the quarter coefficient multiplied by the quarter. So this is the trend. Okay, so I'm getting the intercept and I'm summing up to the coefficient of each quarter and how each quarter is moving ahead, is moving along. Okay, so again, intercept plus quarter multiplied by the respective quarter number. One more time, the last one, intercept plus the coefficient for the effect of quarter of time on the trend, and then the quarter number. Okay, so this is the trend. Okay, this one doesn't have the season factor. This is not the final forecast. This is only